let's go a little bit into what KRAKATOA is, and then we'll switch to Cinema 4D and start doing some magic. So basically, KRAKATOA, as you hopefully already know, is volumetric particle rendering, manipulation, and management toolkit. It's a long description because in addition to rendering, it does some other things to particles, and in the future we'll be adding even more features to the Cinema 4D build that allow you to do even more manipulation of data as a post-process. It's been on development since around 2005. In fact, there was a 2004, there was a earlier version that wasn't called KRAKATOA, and it wasn't a volumetric renderer, but it was a very massive particle renderer that we used on one project, and then we rewrote it from scratch. And we released, initially actually, it was a standalone product, and then we built it in as a plugin for 3ds Max and released in 2007 as a second commercial product. In those days, Thinkbox Software was actually the research and development arm of Frantic Films Visual Effects. So we're in production and we were selling software as a side business. Now we're doing that full-time, only developing software and selling it to people. So our first product was Deadline, which I'll mention later again. And KRAKATOA was the second one. Both are very successful. And last year we released also a version for Maya and the standalone version of KRAKATOA. And then using that standalone, we started connecting it to various products. In fact, the Maya implementation was based on the new standalone core. And this year, on April 14th, we released KRAKATOA for Cinema 4D. And now you can request it, and some of you probably have already received an evaluation version. And all these versions that are currently available, the standalone and the Max, Maya, and Cinema 4D versions, they use the same core in the background. It's just the exposure that is different. And I would say that some of the exposure in Cinema 4D went really well because of the experience that we had with the previous products, and actually we got it integrated even better in some points. KRAKATOA is completely CPU based, doesn't use the GPU for anything. It's 64-bit. It started 32-bit back in the day, and the memory limitations of those systems were really the big problem. That's why it was standalone initially. And nowadays, integrating it into a package that's also 64-bit is very easy because memory is cheap and plenty. And we also take advantage of the many cores that are available on machines. So it's heavily multi-threaded. So basically, I already see a question in the question box which is mentioning a dual Xeon with 256 gigs of RAM, and I wanted to mention that already. In general, when you have, that sounds like a fantastic machine. In general, when you have a choice between more cores or more memory, and especially faster memory, we recommend that you go for faster memory and a lot of it. It scales really well to about, let's say, 8 threads. With 16, you're going to still get faster, and 32 threads will probably also be faster, but it won't be linear and it won't pay off. Really, you would be rendering a little bit faster with a lot more overhead for managing all those threads. So if you can get a machine that is, let's say, 8 cores, with hyperthreading you would get 16 threads. I would suggest that you go for that and get more memory instead of going for like a 32 thread machine that has slightly less memory because you are balancing your budget. So especially if your memory is tri-channel type, which I happen to have, my machine with an i7 CPU was probably, it's around 5 years old. It used to outperform the Xeon, dual Xeon machine that I had in the office, which was using 2-channel memory. The dual channel was just performing slower, and because KRAKATOA uses a lot of memory and memory allocation is more or less the bottleneck, the faster memory is, the better it will perform. It scales linearly, so if you are testing with 1 million particles or 10 million particles, and then you want to render 100 million particles, you know that it will render 10 times slower than 10 million particles. So it's very easy to project your time and meet your deadlines by working with at lower resolutions with less particles, getting the simulation looking right and getting the general settings, lighting and so on looking right, and then producing more particles and rendering them and knowing approximately how long it's going to take to render, because most of the time it scales very predictably. Already mentioned the memory versus the cost, and a quick overview of how we integrated it. We basically support in Cinema 4D all the typical particle sources, including the old style emitter, thinking particles, X particles, which is a third-party plugin, and turbulence LED, which is also a third-party plugin. We also provide some dedicated tools for converting meshes to point clouds, which gives you points really fast, especially for testing or for doing certain effects where a simulation is not really necessary. We also have a PRT loader object which can read external formats, and KRAKATOA itself can save those formats. PRT is our internal. It's actually an open format. We have published the specification, and it's been supported by various products, including RealFlow, Naiad, and there are free tools out there to convert from any particle format to our PRTs. We support also natively the bin file format of RealFlow, so I can read particles straight from there, and you can save them and load them back in RealFlow. And the comma separated value, which is a text format, pretty much any text file that contains columns of data. It's actually row per particle and column per channel, and you can read XYZ LiDAR scans or anything that you can write with a script from any 3D application, or any application for that matter. So potentially you can use it as the least common denominator to share data with other products. We provide some tools to increase the number of particles, either through multiple iterations or procedurally at render time. We use the lights of Cinema 4D, their attributes, without implementing our own lights, which makes it easier to use an existing scene. And we just pick the attributes that are relevant to KRAKATOA and use them. Same for the camera. We have a camera tag that enhances it a little bit, but in general you can use just the cameras and lights as they are. Same with materials and textures, including most of the projection modes and the camera mapping, which is kind of important. And we render most of the time as points. That means each particle is more or less pixel-sized dot. It can cover many pixels, but typically it's a very small dot, which still renders volumetrically. And we also have a voxel mode where it's not just a small point, it's actually, you define the size in word space and you can render any resolution and it will scale correctly. It supports motion blur and depth of field effects natively, and you can then integrate it in your other renderings using compositing,